Oh, got one person.
There it goes.
Yeah, as if by magic.
They can hear us too.
I know. So no more swearing, okay?
Yep, no more swearing. Hello and welcome people that are just joining us and coming in. We are going to just wait a few more minutes for people to roll in and we'll get started shortly.
It's 10 o'clock. Should we give them one more minute?
Yeah, let's give them another minute here. It's still coming in pretty rapidly here. Again, just want to tell everybody, thank you for attending the Scott Labs and Paul webinar to discuss Crossflow filtration. We will be starting here just momentarily, just waiting for some more people to roll in. Give it another minute here.
And I want to apologize in advance for cat noises in the background. I have a very, very old cat who's a bit senile and seems to want to gain entry into this room on every 5 minutes. So if you hear a screaming cat in the background, that's the explanation. Hopefully it won't interfere with the presentation too much.
I can't hear any cat.
You will. You will. I guarantee it. Whenever is the worst time for the cat to attack the door, she attacks the door.
They're still rolling in pretty good now.
Yeah, let's get. I think we should probably get
Okay.
going.
Okay, everybody, we'll go ahead and get started. I'm sure more people will be rolling in as we're talking about this. There will be a Q&A at the end of this that will take some time to answer any questions that you have. So there should be a Q&A tab at the bottom of your screen if you hold your mouse over it, and you can go ahead and ask questions and we'll get to as many of them as we can. And ones that we can't get to, we will go ahead and answer and get in touch with you via email. And this is recorded and will be available for download when we're done with this. So thank you and welcome to our webinar on the power of data, delivering efficient filtration at your winery. Ian, if you want to go ahead and
Sorry, I forgot I was in charge.
Yeah, you got the controls. So thank you for joining us today. Some things that we're going to learn today: common factors that affect filtration efficiency, how overall operating expense, OpEx, can be impacted by poor filtration efficiency, and IoT, Industry 4.0, what they are, how they are being integrated into our lives already. What the latest innovations from Pall can do to help you optimize your crossflow filtration and reduce filtration OpEx. My name is Damon Dudley, and I'm the general manager of the Parts, Service, and Equipment Department at Scott Labs. I've been in the industry for 30 plus years. I've been a little bit all over the place, but specializing in winemaking, harvest, crush pad equipment, and all that fun stuff. Just to let you know, a little reminder that we are in the process of putting all of our parts and service stuff online. So if you are having parts and service inquiries, check out our website. We're in the process of upgrading all that. Just want to talk a little bit, a short story here about Scott Labs and Pall, the cooperations that we've had together. We've been collaborating since 1990. Pall then sites specializes in production, and Scott Labs specializes in technical distribution. Those were the sheet filters and pads, all cellulose sheets, and transferred to sites in the early 90s. Today, Scott Labs is the leader in wine filtration in the US, with Pall products dominating our portfolio. And you can check out a cool article that was on LinkedIn that we did that goes into a little bit about the history and how long we've been working with Pall. And then now I'd like to introduce Ian Rickard from Pall. He's going to be talking to you today about Crossflow.
Okay,
Ian.
Thanks, Damon. Hello, everybody. Thanks for joining. Appreciate you taking time out of your day to listen to what we've got to say. It'll be nice if we could do this in person and not over Zoom, but hopefully for another 2 or 3 months. After another 2 or 3 months, we'll be back to something a bit more approaching normal. Hopefully some of you on the call already know me. I've been with Pall now for 8 going on 9 years. Joined the marketing team about 3 years ago, which is why you never see me anymore, because I'm stuck in an office somewhere. But I am the product manager for Inoflo globally, so hence my involvement with this. Yeah, I've got quite a lot of experience in the wine industry too. Although I realized recently the last time I actually crushed any grapes was well over 10 years ago now. So anyway, that's me. And English, in case you hadn't noticed, hence the picture. So Pall, we'll go just a little one slide on where Pall is. And I know a lot of you already know this. We've been in the wine industry for at least as long as any competitor I can think of, and probably longer. We're counting 130 years now. Trillions of liters of wine are filtered through our filters. And as Damon mentioned, sheet filters were the beginning of it. Inoflo came in the very late 1990s and has maintained a strong position of leadership in wine clarification. We've now got at least 1,500 installations globally. It continues to be a very successful platform for us. We're going to do a few sort of key terms and definitions just so that we're all on the same page. System throughput is basically a function of how much surface area you have and what the flux rate of that surface area is. So if you can get 40 liters per meter squared per hour out of your crossflow and you've got 200 meters squared, then you can get a theoretical flux of 8,000 liters per hour. I apologize for this all being a bit Eurocentric. Probably ought to put it in gallons, but the numbers work much nicer in metric. Typical crossflow flux rates are a range, so hence you'll see flux rates vary according to the wines, but also the machines themselves have an upper flux rate capability and a lower flux rate capability. Flux rates for wine, lower flux rates for harder to filter wines, This is probably fairly obvious, but just to make sure we recap it, and higher flux rates for easier to filter wines. Filtrability, something that you're all probably very familiar with on the bottling line. Lots of different ways of calculating filtrability. Lots of science behind why it is important and how to do it. Very few ways of calculating the filtrability prior to wines hitting the crossflow. There tends to be, sort of, well, it's X NTU, so therefore we expect Y performance, or the percent solids are A, so therefore we expect B performance. But that's really about it. We typically also have in-house standards. Well, this wine last year filtered in this way, and taking into account this vintage, we might expect the same, or we might be different. It's all a bit vague. So just to be clear on that, so then we have a couple of these in the presentation. These are polling questions. So there you go. I'll give you a minute just to answer those. The questions are up. Just click your answers and let's see what we get. The basic here is to see what the common pain points are. I'm not seeing people clicking yet. Is anybody else?
I'm seeing it come through now.
You are? Okay, good.
Yeah.
Perfect. We'll leave that up.
And I see that we have somebody with their hand up in the participants area. If you can go to the chat section for Q&A for questions, go ahead and ask your question in there, and we can get your question answered, please.
Perfect. All right. And I see that it's just I can't see the votes coming in, but I see that apparently they are, so that's good. Yeah, I mean, I don't want to make assumptions on what your pain points are, so it'd be interesting to see what those are. There we go. Okay. Yeah, that fits with what I expected. My time in sales and in bottling wineries, which have been a while ago now, unpredictable filtration results seem to be a pretty common theme. So that's good to know. We're on the similar page.
Good.
Ready to move on, do you think?
Yeah, I think so.
Okay. All right. So factors affecting filtration efficiency. Wine filtrability is a big deal in terms of overall filtration efficiency. What affects wine filtrability? Numerous things: colloids, suspended solids, sugar content, filtration temperature, red versus white, just as the basic simple measure. Reds are typically harder than whites. I have seen on occasion that to be not true, but it's pretty rare. Turbidity is a rough indicator, but could you say with your hand on your heart that a 5 NTU wine is going to filter better than a 6 NTU wine? No. Is a 5 better than a 10? Maybe. Is a 1 better than a 5? Again, depending on all of the other contents of the wine, not necessarily. Is a 5 going to filter better than a 50? Yes, probably. So the point that I'm trying to make is that it's all a bit vague. We've got data, but don't always have enough to make the right choices. The other thing that affects filtration efficiency when it relates to crossflow is the status of the machine itself, whether it's a Pall machine or anybody's machine, quite frankly. The membranes aren't clean, then your throughput is going to be dramatically impacted. The membranes can be regenerated. We all know that. If you've got a crossflow, you know that cleaning is crucial. But knowing that it's clean and keeping it clean are two very important factors in terms of making sure your filtration is efficient. And then also avoiding unexpected maintenance. Preventive maintenance is not really a mantra of the wine industry at every level. It tends to be at the larger wineries, but preventive maintenance or and even better predictive maintenance is is now something that's coming with, and I'll get into that a little bit further, but avoiding emergency break fix situations where the Crossflow is for some unknown reason not working, would be a good thing to do to avoid. So OPEX, we mentioned that briefly. Operating expenses, utility costs, electricity, energy, water, chemical cleaning or cleaning chemicals. Those are an important factor, depends on where you are, what state you're in, depends on very much on what region of the world you're in to a certain extent. Wine losses are an important factor in the operating expense related to filtration. Directly related to frequency of cleaning. The more you clean, the more retentate you generate, and unless you have a way of filtering that retentate, the more loss you incur. Value of wine, we could probably use a value of $10 to $15 a gallon here, and probably half that in Europe. So it's, it does vary greatly by region. Bordeaux to the south of France, again, would be a different value. Wine losses are specific to the system design. So I'm not going to go into the difference between us and the competition, but suffice it to say there are differences. And the filterability and of the given wine will determine how often you need to clean. So performance in filtration has a strong effect on how frequently you need to clean. How frequently you need to clean has a strong effect on operating expense. Okay, I think I summarized that. That's basically what I was trying to say in the last sentence. So the idea is to get the longest filtration run you can to minimize your losses. So here's a scenario to consider. On Friday, your main operator, he or she's been filtering all week, no problem. Same wine all week, no worries. They're getting 40,000 gallons done in 24 hours. Feels good. That's what you would expect. And then on Saturday, the Saturday operator comes in and things are not as good. Now, it may be that you notice immediately. It may not be until you notice on Monday when the winemaker comes in, because I'm assuming that this winemaker took the weekend off. That's not a slight on winemaker. It's just the way I wrote the slide. So, we've got this unexpected loss. What happened? 20% drop. Why? This kind of thing happens all the time in wineries. Unexpected filtration results, and then the knock-on effect of this can be dramatic. Let's go through some of the causes first, though. So, did the weekend operator set the flow rate correctly? And secondary to that question is, did the weekend operator talk to the weekday operator about what the flow rate was he or she was using? Is there a communication issue? Just even a simple thing like that. I've seen lots of wineries that communicate still, with it might be on a worksheet, it might be on a notepad somewhere, but it's a possibility that completely the wrong flow rate was set, even though it was well known to the operator Monday to Friday. Backwash parameters, did they get changed? Now, in reality, I think most operators don't muck around with the backwash parameters. We'll talk a little bit later about how that ought to be different, but maybe that got changed too. Is the wine slightly different from Friday to Saturday? Unlikely, unless they switch tanks and something strange had happened to it. But it's fairly unlikely. Is it possible that on Saturday morning the system wasn't clean? That the guy on Friday had put it on a chemical cleaning, and the guy on Saturday hadn't really verified that it was clean. So there's lots of possible causes. Consequences, as you highlighted in the poll, are bottling schedule, especially if you were planning on bottling all of that Syrah the next week. Now you've got increased operating expenses because you've got to clean more, you've got more wine losses, etc., etc. All of this from a simple, what could have just been a simple communication issue, that the guy on Saturday didn't ask what the flow rate was on Friday. Scenario 2 is also one that I've seen several times, especially usually when I was doing product demos. Um, things happen that are completely unexpected. So you start filtration, everything starts perfectly normally, and then pressure builds really quickly. And the wine that you expected to filter at 1,000 gallons an hour or 2,000 gallons an hour filters at half that rate. Now, in a normal, not in a product demo scenario, but in a normal winery scenario, the winemaker may have one opinion, in this case, that, well, this wine normally filters easily. The operators might blame the filter. They might blame the winemaker, but let's just assume in this case they blame the filter. And maintenance might blame the wine. There's all kinds of things that could be the cause here. Nobody knows in this scenario. And this is really the problem with wine filtration. The beauty of wine is that it's not Coca-Cola. It's not the same thing every day. The headache is that it's always different, and you get lots of unexpected results. So who's right? And how do you know? And how much did this problem cost us? These are all questions that today are pretty hard to answer. You don't know. You don't measure. Most wineries are not measuring the cost of their filtration. There may be some that are on this call, and congrats to you. Well done. But most are not. Most don't have a way of accurately tracking their losses, their chemical costs, their energy costs, all those things. So we're in this today in this reactive state. In scenario one, you could ask the operators to log their activities better so that there is better communication. But it's a manual process that might work for a few weeks, and then go back to having the same issues. Scenario two, you've got to adapt your bottling schedule because the wine didn't filter as quickly as you wanted it to. You're going to waste time cleaning, money cleaning, and you're going to put it down to experience and move on with your life. That's what we all do. But it means the next time it happens, it'll just happen again in the same way. You'll just have to react to it and get on. But it's not the optimal way of filtering. The goal is to filter in an optimal, efficient way every time you filter. So just in quick summary, every time you filter, there are lots of questions to answer. What is the right flow rate? How often should we backwash? Will this wine, well, okay, yeah, that's sort of inherent in the whole subject, but will this wine run as well as it did last time? When should I clean? Which cleaning program? And then sort of more general questions. How do we minimize loss? How much does filtration cost? How do we train new people? And so there's a lot going on with a simple subject like filtration. This applies to cross-flow filtration as much as it does to any filtration, quite frankly, even to leach filtration or bottling filtration. But here we're talking about clarification, cross-flow. So Industry 4.0 and the industry of things. Sorry, it's not the industry of things, the Internet of Things. Sorry, my apologies. IoT does not mean industry of things, it means Internet of Things. I think I changed that last night while I was half asleep. So Industry 4.0 may be a term you've heard. It is out there. This slide basically summarizes it quite nicely. Most things we're doing these days are Industry 3.0. Industry 4.0 is now connecting our processes and using the data in an intelligent way. And that's really, Internet of Things, not industry of things. Internet.
Hey, Ian, Ian, you're cutting out just a little bit. I don't know if you have a bad internet connection or not, but it's just getting a little garbly on there.
Let me, if I lean in a little bit, is that any better?
I think it might be a little better. Let's try it.
Okay. So anyway, Internet of Things, Industry 4.0. We're seeing these in our lives around us. I'm sure many of you have gadgets in the house that are connected with Nest thermostats. And I've got an air purifier that talks to the cloud for some reason in the garage door opener.
Hey, Ian, we can't understand anything you're saying. It's too garbly, or at least I can't. Maybe if you want to, kill your video. Thank you.
Yeah, I killed your video. My video. Is that better now?
Yes, it sounds like it.
Okay, good. All right. So sorry about that. Comcast is not playing nicely today. The Industry 4.0, Internet of Things. They're common now. I think we all have probably some sort of connected device, and it's coming to, well, it's come to industry as well. Many industries outside the wine industry have connected devices. I know that within the wine industry, there's increasing emphasis on connected devices. And I'm going to use the next few slides to show you what we've done with IoT, Internet of Things, not the industry of things, with Pall Crossflow. But the first question I have is the second and final poll, which hopefully we can put up now, which is, you know, what is your level of comfort with having connected equipment? It's I think it's probably
I think we have 3 polls, Ian. I think we have.
Oh, we had a third one? Oh, that's right. There is a third one. You're right. Yep, you're right. Sorry.
Okay, they're coming through.
It's I think if we'd asked this question 10 years ago, we'd probably get a completely different answer.
Yeah.
I know when I ran this recently with a European audience, I was pleasantly surprised as to how open most people were to connecting. I think as long as products adhere to industry standards and connection security, it's not too dangerous of an activity. But look forward to seeing what the poll says.
And there we are.
Okay, so about half of you still not connected. Okay.
Yeah.
All right, well, that again, that's good to see, and thank you for that. And we'll there's some additional data we can share on this product I'm about to talk about, on how we overcome some of the an FAQ on connectivity for any of you who are hesitant. So the next few slides are our latest release of Inoflo. This is the Inoflo Pro XL, launched last year, and this is essentially it's not a rebuild physically of the machine. It's a very similar machine physically to the previous version, but it's a complete sea change in terms of what software it's delivered with and how the software works. And it is a lot more than just a Crossflow with an iPhone app or an Android app. It's a lot, and I want to make that very clear up front. It is not just that you can see it remotely. So Inoflo Pro XL is the first system that Paul's delivered running our new optimizer algorithm. And the algorithm basically runs the filtration. I will go over what it does on the next slide. But also, because it's now a connected system, we now can track all of the data points related to OPEX and then show the reductions in OPEX when the optimizer algorithm is running. So we've basically added a completely new way to run the machine. You can still run it fully manually if you so choose to do so. And by manually, I mean the way you're running one today, which is not manual at all, but you can pick all the settings you want in a manual way if you choose to do so, or you can use the optimizer algorithm, which will now take over all of those responsibilities for you, and the goal of which is to dramatically improve the efficiency of operation. We'll get to some of the data on that soon. So yes, I mentioned it's not just a machine that has an Android and an iOS app, but it does have an Android and Apple app. And so it does come with all the things you would expect: documentation, access to spare parts lists, remote view of what the machine's doing at the time, alarms, all the things you would expect from a connected machine. They're there as well. We now also have a dashboard, PC-based dashboard that duplicates everything that's on the phone, but also provides a lot more detail on batch history full batch histories, pressures, cleaning status, document libraries. So there's a lot of nice features there. And we have modernized the HMI. It was long overdue, quite frankly. So a much cleaner, simpler setup on the HMI. So let's look at the optimizer. It is a new piece of computing hardware in the panel that will, when enabled, take control of the filtration, and it will set within a few minutes flow rate, backwash duration, backwash interval. It will then decide what the intra-batch cleaning frequency is, and it will choose the intra-batch program, cleaning program. And it's going to do that it's very, very simple. You basically push the green button and go. It's not quite as simple as that, but it takes out the need to train people. It doesn't mean that you can just throw them at the machine in 1 minute, they're good to go. But now you can train somebody in an hour rather than having to sort of babysit them for days and days while they learn the nuances of wine filtration. The optimizer is going to take care of that. And it's also going to deliver highly efficient wine filtration every time it's enabled. There is also the caveat that if you choose to disable it, you can do that at any time. So let's look at some of the data. This is data from Europe. Again, I apologize, it's all in metric. This was the baseline operating expense per hectoliter. This is a big winery, 30 euro cents per hectoliter. And that was measured over 5 weeks. And then we enable the optimizer and we reduce it to 25 euro cents per hectoliter over the following 5 weeks. So we demonstrated 17% saving in OPEX, which is not to be sniffed at, especially at larger wineries. You know, that in this case is approximately 10,000 euros saving every year. But what I think is more interesting is that you get the filtration efficiency because of the optimizer. You take the vagary out of your wine filtrations, and you also get to. Let's look at this example. So this is one of the wineries we worked at. Again, you can see the reduction in OPEX. But the interesting thing is that the categories of OPEX, some of them improved and some of them got worse. So we saved money on electricity, water, heating, and on wine loss, but we actually cost the winery more on cleaning chemicals. And it's always difficult to know how often to clean, how often to stop, what cleaning program to use. And in this winery, and which will go certainly not be named publicly, but they were always very hesitant to clean. They thought that using cleaning chemicals was a waste of money, and they did a lot of their cleanings with just hot and cold water. And when we turned the optimizer on, it did what it perceived to be the right thing, and so it used more cleaning chemicals. But we got significant reduction in their operating expense. We also quite dramatically improved their throughput as well. So the optimizer is really taking into account a lot of different things when it's running, and it'll start optimizing within the first 5 to 10 minutes. It'll be at a steady state. Certainly by 15, it's now running, and that's really, you have to give it a starting point. Based on your feeling for what that wine's going to produce, its performance, based on his history. So if you think it's going to do 1,000 gallons an hour, then let's put that in. If the optimizer feels it can do 1,500 gallons an hour, it's going to speed it up. So in this particular case, we reduced our OPEX significantly. Wine losses were greatly reduced. Cleaning frequency was increased though, but the overall was a net benefit to the winery. And here, if we look at throughput improvements, we got pretty dramatic throughput improvements. These are three different wineries, again in Europe. So the optimizer is getting the cycle, because the goal of Crossflow is not to be the sprinter. It's the marathon runner. You want the filter to run within reason as long as possible between cleaning cycles. However, you don't want it to take 24 hours to do something that you get done in 8. So there is a trade-off. There's a sweet spot for speed, and the optimizer is going to take care of that and give you the best filtration performance you can get. So here, I've just said all that. So just a quick summary then. So Inoflo Pro is a connected system. Data will be streamed to the various apps and devices and dashboards. And these will give you history for one machine or however many sites you have connected. So if you're a larger winery group, you can see all the connected machines individually or their cumulative data, and you can pass it however you want. You can also download the data. You can see one site versus another in terms of OPEX. And so these are very useful if you've got more than one machine, especially if you've got more than one site. There are lots of benefits though, all the way across the workflow in the winery. So we've talked about OPEX tracking, OPEX savings. You can expect up to, well, I mean, we say up to an additional 10%. We've demonstrated more than that in our trials. And so that's an important factor, especially at the larger wineries, the OPEX savings. The recording of filtration data, and I haven't really got a good slide on this, unfortunately, but I can certainly add one later. We are now, excuse me, you can enter in batch names and we will develop a batch record, starting pressures, ending pressures, procedures used during the batch, all of that stuff. More important in Europe at the moment, where there are certain governments demanding traceability for audit purposes. So we've built that in, knowing that it's probably going to come here at some stage. So operators, I think, are going to find using the system far easier. The learning curve is dramatically shortened. All of the things, if you already own an Inoflo and you're an operator today, you're going to be able to find everything. It all looks different, but things are in the same place. You know what I mean? So, there will be a manual that comes with it, but if you already own an Inoflo, I don't expect you're going to spend too much time reading it. But new operators are going to be able to just pick up with the machine and run with it. And the owners, the winemakers, the production managers are going to know that those new operators are going to be delivering optimal filtration, because the optimizer algorithm is going to do that for you. And then maintenance personnel, as well as Damon's lovely online spare parts and parts portal, are now going to finally have access to manuals online and our spare parts listings. So something that is long overdue from us. We're delivering that as well. And you will be able to contact well, in this case, it will be a Scott Labs technician whose phone number will be in the app. You'll be able to contact them directly and request service. So now Pall 3, would like to put that up, Damon, just a quick.
There we go, it just came up.
Yep, and see if anybody's interested in learning a bit more. And while you're doing that, if you've got questions, please make sure you submitted them via the chat. I'm here to, if I can't answer them today, Damon and I will get back to you. So we'll do our best.
Mm-hmm.
There is a pretty good, I don't know if Damon, your website links to it, but on the Pall website, which we can include in a follow-up email, there's a pretty good video that we created that can talk you through a lot of the stuff I just talked through as well. If you want a refresher.
Yeah, we can get a link to that if we don't have it already.
Yeah.
We do have one question that came up in the chat field, Ian, that's asking, with the optimizer set, when it sets the parameters, can the operator review them and make changes?
Yeah, so good question. Thanks, Brian. The answer is yes and no. Yes, they can see what the settings are, but if the optimizer is running, then you can't change the settings without disengaging the optimizer. So at which point you're back into sort of traditional manual mode. So it's not quite the same as cruise control on your car, but you can change the speed. I can't think of a domestic analogy. So you basically give the authority to the optimizer to take over, and I'm making it sound a bit Big Brotherish. It's not, we thoroughly tested it, but it will take over. But if for some reason your operator wants to change the speed, wants to speed it up, wants to slow it down, then he or she has to take it out of optimized mode and run it in quote unquote manual mode. And we have data on one of the dashboards that will show what the operating expense looks like in both modes. Because you may have some operators who want to run it in manual mode and some who are happy running it optimized. And I'm sure there'll be a sort of a learning curve and an adoption curve as well as people get comfortable with it. So hopefully that answers your question.
Okay. So we have the results of the poll there. As we have any more slides there, Ian? I think that's the last one, or do we have another one?
Let me find my cursor again.
Yep,
that's it.
Go into questions. That's what I thought.
That's it.
Okay, so anybody has any questions, you can open the Q&A tab down below if you just hover your mouse over it, and we will be discussing questions. I do prefer if they come through the Q&A and not the chat. But we do have one person entered in the chat. What makes Pall membranes better than competitors? Can you run bento cream of tartar through them?
So it depends what you define as better, but our membranes are PVDF. I don't want to discuss specifics about competitors' membranes. What I can tell you is that yes, absolutely, you can run bentonite through them. We have the Inofine system where you can dose bentonite directly into the same membranes we use on all of our Inoflo Pro systems. So Inoflo Pro XL uses the same membranes as Inoflo XL used. We haven't changed that hardware at all. Inoflo Pro XL uses the same membranes as Inofine. And Inofine XL, sorry, correctly named Inofine XL, is our system for bentonite dosing. Cream of tartar. Cream of tartar is, like it is with most systems, can be problematic if there's too much of it. It's abrasive. You can plug the lumen, of the lumen being the cylindrical bore of the fiber if you have too much of it. So you need to be careful with it. I've had experience of systems plugging in a previous life before Pall with cream of tartar. I've seen issues once in a while with cream of tartar with us. And I know that, too much cream of tartar is never a great thing for Crossflow. It's mainly, I think, in some cases, with some, not with Pall, but with some technologies, the abrasion can be problematic.
Thank you, Ian. We've got another question here. Given the wine quality can change batch by batch, to what extent does the machine adjust mid-batch as opposed to making modifications in between batches?
So it's good. That's a great question. And I wish I had the data scientists who developed the software here to answer that specifically. I can tell you that it's constantly adapting during the filtration. So although I said it reaches, it gets to a steady state within the first 10 to 15 minutes, if the incoming wine changes, assuming that the tank is poorly mixed or something like that, the machine will adapt. So, you know, if you've got 5 tanks of theoretically the same wine that you're going to filter, and it's not going to use the same settings unless the wines themselves perform the same. It is measuring in real time the performance of filtration of a given wine and adapting to it.
So that would also come into effect, Ian, if you had a large tank that might have stratifications in it of different, you know, difficulties, which tends to happen quite a bit on these. So that's a good thing.
Yeah.
Now we got another question here. At what scale, how you found what size does the filtration system pencil out for small to mid-sized wineries? So for, you know, we did this study on larger wineries for sure. What kind of pencils up for the smaller ones?
So the smaller wineries, the XL4S and XL, so Inoflo Pro XL4S, XL5S, XL6S, those are the right systems for smaller wineries. And by smaller, I mean wineries, you know, in the sort of, you know, maybe 30 to 30,000, maybe 30 is a bit small. Damon, jump in here if I'm saying stupid things.
I'd say, you know, that 25 to 30,000
okay.
Range is about the beginning for sure. It is a little small, but some people like the quality.
Yeah. You know, I mean, it is possible to buy more Crossflow than you ever need. I mean, I used to say that nobody ever bought a Crossflow that was too big. That's not true. Once in a while, people do. But generally speaking, more filtration capacity is a good thing. The losses with Inoflo are very, very low, and typically in the 0.1% range of incoming wine volume. Might vary depending on, it's a very, very difficult red. But so yeah, that will be a 4-module system from us. Smaller than that, we do have some other small systems. They're not currently equipped with the Inoflo Pro software. Although watch this space, change. But for now.
And yeah, typically I would say that the Pall 6S is probably more the staple for those small to medium-sized wineries that is being used out there. It's nice because it can be reduced down to a 4 pretty easily, and you can run it up to a 6. So if you're looking for something in that range to grow into, that's a nice suggestion. So, but yeah, that's probably the 6S is probably the staple that we definitely turn over the most.
Perfect. I do see a question in the chat. How do you define flow rate of filtration based on turbidity? And the answer to that is you can't. You know, you can only loosely do it. Sorry, I'm saying you know a lot.
Yeah.
You know. You know, 10 NTUs from, you know, Pinot Noir in Oregon versus 10 NTUs from Merlot in the Central Valley. It's going to be 2 different filtration rates. And that's really the point, is that the optimizer is not taking data provided to it about the wine. It's actually measuring the performance of the wine in real time. So it's delivering the flow rate that is appropriate to that wine every time, as opposed to sort of saying, well, you know, this is what we think it's going to do, and then on occasion being pleasantly surprised because it does much better, or on occasion being sadly disappointed because it filters at half the rate. Now we know that the optimizer is going to deliver the right filtration rate every time, and in most cases we've seen dramatic throughput improvements as well.
Yeah, and I'd say one thing I stress very highly is, you know, turbidity is not measuring of the size of particles, it's measuring the amount of particles. And when you're trying to filter through a Crossflow at 0.2, that's why it's so hard to say how it's going to filter on there, because if they just happen to be large, large particles, it's going to filter really good and act as a scrubbing agent. But if those particles happen to be very small, it's going to be a very hard filtration because it'll act as more layers over the holes than bouncing off like the larger particles will.
Yep. Yep.
Okay, we got another question here. Pall high solids machines also offer this capacity?
Not yet.
Capability of the Pro?
Not yet.
Not yet. Okay.
I will say that one thing I haven't mentioned is that existing Pall Inoflo XL systems, XLS and XLA, all of the systems in the US except the very old ones, existing machines sold since 2007 can be retrofitted with this software. That's on a case-by-case basis as to what it would cost. Some of them will be easier than others. And, we discuss that on with Damon and whoever's interested.
Yeah. We have another question here about the Pall Fit. Does it have the optimizer?
No, it does not.
So yeah, the S line of filters, which we represent as the 4 and the 6, and then the A line has it as well, which start at an 8.8 and goes on up.
Yeah, and as you probably read between the lines there, we are going to roll this out to other platforms. I just can't give anybody timing on that yet.
Okay. We have another question here about available mobile monitoring. Is it capable, and can I use it on my phone and check the status of the filtration?
Yes, 100%. You can see, how far you've done based on the volume you said that you needed to get filtered. You can also see how far along the cleaning cycle is. You can also directly look at the levels of the tanks in the what we refer to as tank 1, tank 2, very imaginative. The machine, the filter tanks on the filter. You can see those levels. You can see all of the sensors in real time, all of the analog sensors, pressure, temperature, all that stuff. So yes, there's one screen on the phone and on the PC dashboard that is designed to mimic one of them.
And correct me if I'm wrong here, Ian, but you can actually from the phone app pause the machine.
That's true.
That's true. You cannot stop it, but if you happen to see something that needs to be dealt with, you can pause it.
Yeah.
But you do not have the capability to restart it without being in front.
You can pause it, or if you're the site supervisor, customer's supervisor level, you can disable that feature. You can also track who paused it. So if somebody decides to pause it when they're at the bar at night just to muck with their friend who's on night shift, we'll know. So
that's a good one.
Yeah. But yeah, that's good. There is a pause feature that comes only on the app, not on the dashboard. So there's what else is there that I didn't mention? The dashboard I probably should have gone through in a bit more detail, but other than just visualizing the live data, there's if you need to store records related to the machine, for example, I don't know, you've got a purchase order for something that related to the machine that you want to associate with the machine, or a training document that you want to associate with the machine, or anything. There's now a place for it, and it's all it lines up the documentation thing that I think's been missing for quite a long while.
And if anybody would like more information, we can definitely get you the information. We can also set up a one-on-one meeting where we can actually dive into a machine running, and I can show you what is there in the background, the things that you can actually see and the things that you can do. It's really cool, very, very impressive. Probably one of the things I felt that was very, very impressive on there that a lot of people overlook or have problems with is the maintenance records. And not only just keeping track of them, but knowing how many valve strokes you have, how many hours your motors have run on there, and when do you need to replace that. All that information is on there and gathered so you can see it to be able to do your preventative maintenance to maintain your uptime. So it looks like we're about done. So let's wrap this up. Any questions that we did not get to, we will go ahead and reach out to anybody by email, and get with you. And the people that requested more information will be in touch shortly. And this presentation will be available for download on our website when we're all done with this.
Once I've corrected the slide that said industry.
Yeah, right. So I want to say thank you, everybody, for your time today and joining us in this presentation. And we look forward to talking with you. Thank you.
Yeah, thanks for your time, everybody.